Welcome to another week, and we are discussing file systems and files. So file systems is a very important component for every operating system, and its role is to implement the concept of files. And so the file system consists of two distinct parts. The first is the collection of files, and when we say a file, it's mainly, again, a named collection of data that is managed on secondary storage, for example, disk, by the operating system via the file system. And so each file will be storing some sort of data. And then the second part of the file system is the directory and the directory structure, which organizes and provides information about all the files in the system. And so any kinds of data can be stored in files, and of course the content is defined by the file creator itself. And there are many different file types, for example, text files, source files, executable files. And the structure of the file itself can vary. It can be just a sequence of bytes or words. It can have simple basic structure like lines or fixed lengths, or it can have some more complex structure like formatted documents or relocatable load files. And so, as you know, every file consists of data and metadata. And so the data is the part of the file that is visible to the user, whereas the metadata, it's the data about the data. And so it is the information about the format and the organization of the file itself and the data that it contains. And it's generally stored in a file header. And so the file header is that portion of the file that is in the beginning, and it precedes the actual data, and it's only visible to the file system itself. And so there's something called the magic number, which is a small sequence of characters that is usually found at the header, and it identifies uniquely that file, the file type, the type of that file. And so, for example, when we're talking about a source code file, then the magic number will identify the programming language and other information that are relevant to the compiler. And so, of course, the other way to represent a file type is using the file extension, right? And so, again, the file extension is that sequence of characters, right? .txt or .c that follows the file name. So the file extension can be really not hidden to the user. The user can see the file extension, while the magic number, it is internal to the file system and it's not visible to the user. And so the file extension is more convenient to use as it can be examined by the user. But the main problem with the file extension is that it can be easily changed, right? We can easily change a .c extension to .txt, right? But that doesn't really change the file type itself. So there are multiple types of operations that we're allowed to execute on a file. Of course, to create a file, write to a file, read from a file, delete a file, open a file. And so if we think about a simple operation like opening a file, if we look in the background, there is a series of instructions that has to be executed in order to open a file and also manage the open files. And so we do need a table to keep track of all the currently opened files, and we need a pointer that will point to the last read or write location and we're going to need things like a count of the how many we have currently files that are open. We're going to need things like the disk location of that file, as well as the access right to that file. And so when it comes to the list of open files, there's two types of data structures to maintain that and track that. There's per process table, so every process will have its own table to keep track of the different files that were opened by that process. But there is also a system-wide table that keeps track of all the files open system-wide. And so there exist different access methods to a file, and when we say an access method, it's really the set of operations that are provided by the operating system as a user interface to enable us to access that file. And so the most common one and the straightforward one is this sequential access. And so the file system will just maintain the current position within the file, and then each read or write operation will access the next n bytes or the next record in that file. And so the operations with the sequential access will be read next or write next, or really reset, which will rewind you to the very first record in the file. And then other operating systems can support other types of file access, namely the direct access method, where a record can be directly accessed using a specific record number or a key value. And so there's no restrictions on the order of reading or writing as it was before with sequential access. And so, for example, we may directly read block 14 and then read block 100 and then write block 0, for example. So there is no specific order when it comes to the access operations with direct access method. And there are other file access methods in addition to that.